Hello everyone, let's look at this integral here. We are going to do this integral by using the substitution method, and we also call that the U-sub method. And so why do we know that this is a U-sub method? It's because if you look at this, this is a product, but just because it's a product does not mean that it's we got to use a U-sub method for this one. But as you know, that for a product, we cannot integrate directly. If it's addition between the x squared and the square root of x cubed plus 5 or subtraction, then we can integrate term by term. But because that's a product, so we cannot really just integrate this one and the square root separately and then put them together. We cannot do that. And so the other indicator for why it's a U-sub problem, it's because let's look at this inner function inside the square root. This x cubed plus 5. When you take the derivative, the x cubed plus 5, you are going to get 3x squared, and that x squared, it's related to this x squared right here. So that feels like there's the chain rule is involved in here, right? So, and the U-sub method is really just a process of reversing the chain rule. So that will just tell you, okay, so we are just going to try U-sub and see what's going on. Okay, now let's get started on this problem. We are going to let u be this inner function here, the x cubed plus 5. And so we'll start by writing u equals, and then x cubed plus 5. Okay. And then what do we do next? We are going to take the derivative of this function here, the u, because we're writing u as a function of x, right? So we are going to differentiate this u with respect to x. Then we are going to get the du over dx. And that's equal to, what is that? That's equal to 3x squared, and then just that. The 5 will become 0, so we don't have anything more. So we just have the 3x squared. And so as you can see here, there was this x squared, there was that x squared, but then there was some more work that we need to do here because there was only the dx here. We also need to replace that dx when we make a u substitution. And so what do we do here? We can treat the du and the dx as differential. So we can actually multiply both sides by dx so that we can get the du by itself. And so if we do that, then we are going to get du equals 3x squared dx. Okay, so now we have this. And that's not finished yet, because when we replace the dx, we actually need to just make sure that everything that we have here on the right hand side, and then we can make the substitution and change that into a du. How do we do that? It's this. So first we look at the integrand. We have the x squared, and we also have that dx, the differential at the end of the integral, right? And so as you can see here, we do have that x squared and then the dx. So if you are doing some highlighting here, then you see that there was this x squared and then there was this dx right here. And then we also have that x squared and then the dx right here. So actually, we do have that x squared and the dx. We just don't have the 3. So what do? We can get the 3 to this side of the equation. And so if we multiply both sides by 1/3, then we are going to get 1 over 3 d times du is equal to this stuff, right? The x squared dx. And so that's really just the stuff that we had. Okay, now that means this x squared and the dx can be replaced by the 1 over 3 times the du. Okay, so now let's go back to the integral, and then we can start making the substitution. Okay, so we have what? We have the integral symbol, and then now the x squared times the dx is replaced by 1 over 3 times the du. So I put the 1 over 3 in the front first. So 1 over 3, and then I will put the du at the end. But right now, I just want to write down this, the other stuff, the square root of the x cubed plus 5. And how do we do that? The u is actually x cubed plus 5, so I can replace that holding by u. So I'm just going to get the square root of the u. Okay, so that's good. And then don't forget that we actually just put down the 1 over 3. We haven't put down the du yet, right? So I can now put it right here. So now I have a new integral, which just looks like 1 over 3 and then times the square root of u times the du. So one thing that I should really point out is that if everything is done correctly in the u substitution and the problem is a u-sub problem, then we are just going to get just the u in here. There is no more x, which is the original variable. So we shouldn't see the original variable anymore for the new integral that we are obtaining here. And yeah, so as you can see, there was no x right here. Okay, so what do we do? There was this 1/3 here, so we can move it outside the integral, right? We don't need to worry about it. Get 1/3 integral. At the same time, I can actually change the square root of u into the power form so that I can reverse the power rule. So I'm just going to get u to the, 1/2, right? That gives you the square root. And then there was the du that we need to copy down here. Okay, so now it becomes a really simple integral that we need to integrate. Using the power rule here, we can get 1/3. And then now, because we're integrating, so the integral symbol will disappear. And what am I going to do? I'm going to add 1 to this power right here. So I'm just going to get u to the, if you're adding 1 to it, then you are going to get 3/2. Is that okay? So what we are doing, let me just show some work right here on the side. And so what we are doing is that 1/2, if you add 1 to it, that's 1/2 plus 2/2. So we are going to get 3/2. So that's how we can get this 3/2 right here. So this green number right here comes from here, so we get the 3/2. Now, what do we need to, why did I leave some space in the front? We actually need to, we're reversing the power, right? So we actually need to multiply by the reciprocal of this power. And its reciprocal actually would just be switching the numerator and the denominator. So I get the 2/3. And then we close the brackets. Okay, so that's that. The integration step is done. So all we need to do right now is to replace the u by with this x cubed plus 5. Then we are finished. So let's do this. We are going to, and at the same time, we can actually multiply the 1/3 and the 2/3 together to get just a single coefficient, which is 2/9, right? 1 times 2. 1 times 2 gives you the 2. 3 times 3 gives you the 9. And then this u becomes what? It's x cubed plus 5, right? And don't forget that there was actually a power on the outside. There was that green power on the outside, so I just gotta copy that. And then I have that x cubed plus the 5. And then adding the constant c. Okay, so we're done with this problem. Okay, so regarding this problem, this is actually the first video in the U-substitution that I'm doing. I'm actually going to do a big series of U-sub problem. There are different cases where you may need to do more work when you're doing the U-substitution. I will do more on those ones later on. Okay, so this one is simple, but just keep in mind that there is one thing that's important, is that after you finish making all the U-substitution, there should not be the original variable anymore. If there is still the variable here, either it's not a user problem, or it can be there is something wrong, or you may just need to do more work. Okay, so that's it for this problem. Thank you for watching. If you like my video, please subscribe my channel. I'm going to continue to make more videos on calculus, algebra, and eventually higher level math. Okay, so thank you for your support. See you next time.